So for this episode, we are going to continue to work with our geospatial data. Up until now, you have had practice working with raster data and vector data. And in addition, with the raster data, you've also had practice handling situations where you have different projections of your raster data. For this episode, we will deal with different projections of your vector data and whether or not data with different projections can be plotted in the same plot. For this episode, we will be working with the United States Census Bureau map of the United States and some of the data that we worked with for the Harvard site from earlier episodes. Now, why is it even important to consider working with vector data that potentially has different spatial projections? Well, turns out that can be a really common scenario you might find yourself in. Now, you could have gotten data from different sources. Maybe some you downloaded from Neon, for example, and then some you downloaded from another source. And just because of the different projections that they use as standard projections for their data, they may be in different projections when you get them. And now it will be your task to be able to reconcile those differences or potentially just use them as is. So handling data with different spatial projections is a really common task for working with geospatial data. Now, what do we mean by having different spatial projections? Well, here are 4 different maps of the United States. All of these look about right. So the contiguous states we have here, there's, the familiar shapes and kind of the right size. But each of these 4 depictions of the states have different projections. And we could see that these different projections means that how the states are depicted or their size and arrangement and shape of the states is different for each of these projections. So for example, this Mercator projection, we have the top of the United States is very flat. And it could seem kind of stretched out. That's in contrast to the one below it, which is the U.S. National Atlas Equal Area projection, where we have the United States, the top of it represented with this curve, and the whole United States seems more narrow. Similarly, we have this UTM Zone 11 North projection, or this WGS 84 projection, which each look different than the others. And so these projections matter not only in how they're represented on a map. Say you wanted to make a map of the United States or a particular part of the United States. But these projections also matter if you're going to do any other type of geospatial analysis. So it's important to, one, be able to recognize when you have different spatial projections, and 2, to be able to understand how those projections may influence your geospatial analyses or your map creation. So we are going to work with the data from the U.S. Census Bureau of these state boundaries. So we will go into RStudio and import some data that we have of the United States. In addition, we will also use some of the data we have from the Harvard Neon site. So I've opened up RStudio using the R project that we have created before. So from my Geospatial CARP folder, I clicked on the .rproj file that we had created in other lessons. So here I have my standard RStudio setup where I have the console on the left, my environment on the upper right, and my environment is empty, and other various things on the lower right. So here I'm showing the files, and because I'm using an RStudio project, it's listing the files that are associated with this file location. And then I also have things like the plots or the help for R. So we're going to go ahead and create a new R file. So to create a new R file like we've done before, I'm going to do File, New File, R script. So that's one way to do it. Remember, you can also access it within the RStudio window here if you're on a Mac, where you have this plus icon, and click the drop down arrow and create a new R script. So we're going to create a new R script specifically for this episode. We're going to give it a few helpful comments in the beginning so that if we come back to this R script, we will remember what we were doing. So to make a comment, I am going to use the pound or the hashtag symbol, and then anything after that wouldn't be run in R. It's just a comment for us to read as humans. So I'm going to start off by just titling this R script. So I'll use the hashtag symbol. I'm going to call it Handling Spatial Projection and CRS in R. Give it my name, a date, so July 2020, and then a brief description of what this script is going to do. So this script is going to plot vector objects with different CRSs in the same plot. Okay, so we have created our comments, so we know what this script is doing. And now I want to make sure I save this script. So it's called Untitled1 and it's in red, meaning it's not saved. So let's go ahead and hit this save icon to save it in our scripts folder. So I will call it episode 9, Handling Spatial Projection.R. And you can name it whatever you'd like. That's just the naming system that I'm going with. And hit save. Okay, so usually when we start a script, the first thing to do is to load the relevant libraries or the packages that we will be using. This will be a fairly simple script, and so we just need a couple of the libraries that we've seen before. Specifically, we're going to load the SF package and the ggplot2 package. So the SF package allows us to load spatial data, and then the ggplot2 package is for plotting. So I'm going to do a comment, load packages, and I'm going to use the function library to load those packages into this R environment. Now, you should already have these packages installed. If you don't, you can go back and take a look at the episode or the setup page for how to install those packages on your computer. So once they're installed, all we have to do is call them into RStudio using the library function. So I'm going to type library and then the name of the package. So we're going to use the SF package, and then on a new line, type library parentheses ggplot2. Oh, not 1, 2. Okay. So we're going to load these packages, make sure they load. I'm going to do that by highlighting with my cursor both of these lines and then hitting the run icon up here. Okay, and that's all right. We got a little notice from R saying it's linking. None of this is a warning. It's all good. We can continue to move on. The other important thing to do when you're starting a new R script is to load all the necessary data that you will need. So I'm going to create another comment where I'm going to load data. And the data that we're going to use for this episode comes in from a few different locations. One of the pieces of data that we're going to use is something that you may already have installed or loaded into your R environment if you're coming directly from another episode. And that is one of the point locations for the Harvard site. So the field tower location. So you might already have this installed, but if you don't, we'll go through it and install it again. So we're going to load that point location. So we're going to call it point underscore harv to indicate it's a point vector object for the Harvard site. So we will assign that object. And to load vector data, remember we are using the stRead function of the SF package. So I'm going to write st_read, open my parentheses. And within this stRead function, we want to point it to where that file is saved. So whenever we're talking about a file name or file path, we need to put it in quotes. So I'm going to open up a pair of quotes by clicking just once, and it'll automatically do double quotes for me and put my cursor inside. So the data that we're going to use is in our data folder. So I'm going to start typing data, and then I'm going to keep doing tab complete to always navigate through my folders. So if I hit data and then I hit tab, RStudio will help me out and open up this directory that I have here. So I can keep hitting tab and it will auto fill in whatever thing I have highlighted. So I want to go in the data folder. So I'm going to hit tab again and it does this /. And now we're going to look for our point location, which is our vector data. So I'm going to start typing vector until vector is highlighted and hit tab. And then we're in our vector folder. And so we want the Harvard data, but we specifically want the Harv Tower data. So here now all of the Harv Tower data is highlighted. And notice here I don't have the same capitalization, but RStudio is like, that's all right. I will show you what I think you're looking for. And I can either use my mouse to move up and down this list or my up and down arrows. And with the stRead function, we specifically want to point it to the .shp file within this suite of files that make up a shape file. So I usually like to use my cursor once I'm at this point and click on the shape file. And so RStudio has filled in the rest of this file name for me. It did the correct capitalization and then it finished this file name and the extension. And that's important just to make sure that you don't have any typos. So let RStudio help you by preventing some typos that can be very frustrating to figure out. So let's run this line of code just to make sure we have the right path and just to make sure the function is working properly. So I'm going to run this line of code and our point Harv object pops up in our environment. So that's good. The other data that we're going to load right now is the US boundary file that we have saved in our folder as well. Now we haven't worked with this yet, but we're going to use the boundary data that we have in the vector folder. So we'll call this our state boundary US. I'll just remind you what it will look like. So it'll look similar to this, but it's going to load and we're going to create a map like this. So we're simply loading this vector file that has the map that has all of the state boundaries. So let's load that into our environment. We're going to call it state underscore boundary underscore capital US. And again, because this is a vector data, we'll use the function st_read. And we're going to point to our data file by opening up some quotes. It will be in the data folder. I'm using tab complete. It'll be in the vector folder, tab complete again. And the file name starts with US state boundaries. And it's this state boundaries census 2014 file. So again, I'm using my mouse to scroll to or to click on the US state boundary census 2014.shp file. And it will automatically fill in that for me. All right, and let's run this line to make sure we have it. Great, so now we have the two data files that we're going to use initially into our environment. We'll save our file to make sure we don't lose it, and then we'll go on to plotting these data. So now that we have loaded our data, so our point location from Harvard and our state boundary layer from the US Census Bureau, we're ready to start creating a map. So remember, the purpose of this exercise here is to create a map with data that has different spatial projections. So let's start to map the data that we have loaded. I'm going to write a comment here that says create a map of the states. Okay. So we're going to go back to creating maps or creating figures with our ggplot syntax. So we're going to use the ggplot structure for creating all of our maps. And we did this in some previous episodes when plotting some of the raster data and the vector data, and we'll continue to do that for this exercise here. So I created a comment here, and I'm just going to start with my ggplot syntax. So the command that we start with is ggplot, and we're going to use that function. We're not going to put anything in the function there. That's just telling it to open this instance of a ggplot. And for all ggplot lines, we need to finish the line with a plus sign, just to tell ggplot and to tell R to keep going. We're not done with this plot yet. We're going to add data to our plot. So the first thing that we're going to add is our state boundary. So to add our vector data, it's the function GEOM_SF, and we'll open the function brackets there. Now this function is looking for a data layer. So I'm going to specify data equals, and then put the name of our data that we want to map, which is the state boundaries of the US. So data equals state underscore, and as I start typing, remember RStudio is trying to help us out and save us some time. So it's highlighting this object that we have, which is our state boundary. I'm noticing here though, as I'm doing this, that I don't actually have the things in my global environment. So I'm just going to quickly load this stuff. I had it loaded before. Okay, so we've specified GeomSF as our state boundary. We're going to keep going with this map because we want to give it a title. So we'll finish this line with a plus sign and start a new line. For this new line, we're going to use the function ggtitle, ggtitle. Open the parentheses for the function. And in this, we're going to put the title of our map. So we're going to put this in quotes. So I'm going to open my quotes, and within the quotes, give it a title. So I'm going to call this map of contiguous US state boundaries. It's spelled contiguous, right? T-I-G-U-O-U-S. Okay, I'm not quite done, so I'm going to finish this line with a plus sign and then use the function that we've seen before, COORD_SF and the parentheses, just to give our map some coordinates. So that's all that we have for our ggplot figure. So to create this figure, I'm going to highlight all of the lines as part of this ggplot block and then hit run. And it may take a second here, but we see that our map has come up on this right-hand panel where we can see the map of the US state boundaries that we plotted here. And then we have our coordinates as degrees on the Y and the X axes. So great, we've created our maps, but let's make this map a little bit more exciting. We want to add a few things to our map. So we're going to add a boundary of the US. So here we're going to add a that boundary that encompasses the whole contiguous states, just to kind of make it look nicer and add some definition. And then what we really want to map is our point location. So we want to map our Harvard point location over here in this region. So the first thing we're going to do is load this boundary. So it's going to be a new layer that we want to bring into and add to our map. So I'm going to make a comment here saying load country boundary. And just like we loaded the data before with these stRead functions, we're going to do the same process, but load our country boundary. So I'm going to assign it the object name country underscore boundary underscore US, capital US. I'll assign it to that object name and then use the function st underscore read. And as we've done before with this function, we need to open our quotes and within the quotes point to where that data exists. So I'll use tab complete to navigate to our US boundary layer in our vector folder. So I'm going to go into the data folder, tab complete, into the vector folder, tab complete. And the file that we're looking for is US-boundary dissolve. Okay. And again, RStudio is helping me out. It pulls up the file names that start with this text. And so I'm going to use my mouse to click on that shapefile. So we're opening the US boundary dissolved states. And now dissolved might seem like a funny word. And you're like, why is it called dissolved? Dissolved is a fairly common geospatial operator. So if you've done work in GIS, you might have seen dissolved. If you haven't, that's okay. Now you can be on the lookout for when you might see it before. Essentially, it's just eliminating the lines within this file. So essentially, we've dissolved or we've eliminated all of the state lines, and so we just have this outline border. And when we map it, you'll see what I mean. So we have this line here. I'm going to run this line by doing command return. And we see it has been added to our environment. So let's go ahead and add this to our map. The nice thing, remember, about ggplot is that we can build plots by simply adding lines to this ggplot block that we have. So because I think it's a good time saver and it's a good way to make sure that you keep adding to a plot that actually works, I'm going to copy the ggplot script that we had above and just paste it down here and give it a new comment. So I'm going to say, create a map of the states with a country border. So again, I just pasted the same plot that we had here that created this map down below, and we're going to add to this ggplot block. Okay, so how we add to our map is simply by creating a new line. So I'm going to go to this Geom-SF, and I'm just going to hit enter so I create a new blank line. And here I'm going to do a line that looks similar to this. So I'm going to use the Geom-SF function, and I'm going to change the data argument that we have inside to now give it this country boundary US data. So I have the same ggplot block. I created a new line, and I'm going to use the same function, Geom_SF, open parentheses. And within that function, I will specify data equals country boundary US using tab complete there. And again, because this is ggplot and we want to tell it to keep going, I'm going to finish that line with a plus sign. Okay, so this has now added the country boundary to our map. But because I want to make it look a little bit nicer and I want to have a thicker line for this country boundary, I'm going to add an argument for size. So within my Geom-SF function, I'm going to do comma, and specify size equals 2. And that tells ggplot to make the size of this line bigger. Okay, so to run this set of lines, I'm going to highlight the whole thing and hit run. And then our new map, our new figure will show up in the plots. Great, so here we have our new map. It looks similar to last time where we have our states and then the Y and X coordinates, but now we have this nice outline of our country. So by adding this line, this country boundary, and giving it a size of 2, we've now added a nice thick border to our country, but we have not changed anything about the state lines. Okay, so that just made the map look a little bit nicer. And what we want to do now is add our point location for Harvard. But before we do that, because we're using data from different sources, let's check to see if our data is in the same coordinate reference system or if our data uses the same projection. I'm going to go ahead and save this just because saving often is good practice. And for now, we're going to, before we do more with our map, we're just going to explore data projections. So I made a comment here to explore data projections. So to do this, we are going to look at the CRS information for our vector files. The function that we use to do that is st_CRS. So if we do stcrs, and then within the function, we can give it the name of our object that we want to explore. So let's first look at our Harvard point location. So within stcrs function, we'll do point_harv. And now we can look at the CRS object. So the output of this, because we're not assigning it to anything, the output of this ends up in our console. And wow, look, we got so much information about this coordinate reference system here. There's a lot of useful information in here, but I find that this output is a little bit overwhelming and kind of too much information for me. So rather than looking at the base output of this stcrs function, I want to specify that we just want the project string. The project string is going to tell us all of the information that we need to know. So I'm going to append this stcrs line with the $sign and type proj for string. And that's kind of an unusual name, but it's just the notation for getting this project string. So we have stcrs, the function for our Harvard point data, and we're using the $sign proj for string. So I'm going to run this line. And the output, again, because we're not assigning it to anything, ends up in our console. So here we have the output of our project string. It's much less information than what we had before, which is good. So it's a little bit easier to understand and interpret this information. It's giving us really useful information. So this part of the project string is the projection. So for this Harvard data, our projection is UTM, so Universal Transverse Mercator. Because we're in UTM, we have a zone associated with it. So we're in zone 18. We also know the datum of our data. So remember, the datum is kind of like the sphere that we're using to represent the world. So we have the WGS 84 datum. Our units are in meters, and then we don't have any specific definitions. I think that stands for. So great, we're able to get a quick picture of the projection for our Harvard data. Let's do the same thing with our other data points just to see how they compare. So I'm back up here in my script. I'm going to type st_CRS again, open that function. And within this function, I want to take a look at one of the US boundary data. So let's look at the state_boundary using tab complete there again. Again, I'm going to append this function with $sign proj for string and run this line. So the output of that is in the console. So let's look at the project string. We have the projection as latitude, longitude. So that's different than up here where we had UTM. We have the datum as WGS84 and similarly no definitions. So what we're missing from this project string is a zone and a unit. And that's because this lat-long projection just deals with this data as degrees. So we haven't translated this state boundary layer into the UTM projection. So we haven't given it like a unit of meters. We're just dealing with like the degrees that exists on the globe. So we know we have different projections here. We can do the same thing to look at the other country boundary we imported. So I'll do the same thing, st_CRS, st_CRS. And within the function, I'll put the country boundary, US, tab complete, and then I lost my closing parentheses, so I'll add those back. And then $proj for string. Okay, so I ran that line and the output is in the console, and the output of the country boundary US is the same as our state boundary US. So looks like we have two different projections here, one for our Harvard data and then one for our US country data. So that's good information. Let's explore this a little bit further and think about the extents that we have. So we're gonna use the function, write a little comment here, explore data extent. And so that will tell us a little bit about like the geographic range of the data. So how, like where in space the data exists. And that's also useful for us just getting to know the projection of the data. To do this, we'll use the function st_bbox. So st_bbox. And within that function, we'll give it the data that we want to look at. So first, let's look at the Harvard point data. Point_harv. We don't need to append this at all. We'll just run this line and look at the output. Great. So the output here is giving us xmin, ymin, xmax, and ymax. And these are all positive numbers, like in the multiple thousands. And because we know from above that our units are in meters, we can interpret these as meters. So our xmin goes from like 732183.2 to our max of 732183.2. Okay, and that makes sense actually, because it's a point. It doesn't have dimensions, 2D dimensions. So actually, in looking at this, we don't have xmax and xmin, but what we do have is our meter location on the ground. So good to know. Let's do the same thing with our state boundary. So st_bbox, and then we will do our state_boundary object. We'll go ahead and run this line. And so the output that we get here is different in a couple ways than from the point data. One is we have different units. So rather than in the 73,000, we have a negative 124 and a positive 24. And that's because these units, because we're in latitude and longitude, these units are in degrees, and specifically decimal degrees here. So we're 124.7 blah, blah, blah degrees minus, so in the negative direction, and then we're 24.49 degrees positive, so in the northern hemisphere. So that's useful. And we also are seeing a difference between the xmin and the xmax and the ymin and the ymax. So here, this is supporting what we know about this data, where it's not a point, but it actually covers some area. So we have some differences there. So that's good. We have now learned that we have different projections and different extents. And so because the purpose here is to plot the data, let's think about if we need to treat the data in any different way because of the different projections. The cool thing with vector data, unlike raster data, is that because they are existing with the same datum here, so WGS 84, we don't need to do any sort of reprojection for these data. So in the previous episode, you had to reproject raster data to get them in the same projection. But for vector data, for the plots that we're going to make, we actually don't have to do that. So even though we just learned that we have some different projections and different extents, and some's in meters and some's in degrees, we don't have to make any changes to our projection. So what we can do is just add our Harvard data to the plot that we already created. So I'm going to make a comment here. I'm going to say, create a map of the states with the Harv tower location. Okay. I'm going to go up and copy the ggplot block that we had before, where we have our country boundary US and our state boundary US. So I'm going to copy those 5 lines, and I'm going to paste it down below. And again, I'm doing this because I know this code works, and I'm just going to add to it. So we're going to add our point data now, and we'll do it below the other 2 data layers. So we have 2 lines to get our country boundary and our state boundaries, and I'm going to create a new blank line under those 2. So I've just hit enter, and I created a new line. And in here, I'm going to use the same function, geom_sf, but I'm going to tell it to plot the point location for the Harvard tower. So I'll type geom_sf, open that function. And for the data argument, I'm going to say data equals point and the Harvard. So that will add the point to our map now, but because I want the point to stand out a little bit, I'm going to use some arguments within this function to make it look different. So just like we did up here where we changed the size, I'm going to change some attributes of this point. So within this function, I'm going to do comma shape, S-H-A-P-E, shape equals 19. That's just a shape a number or a code for a shape that I know. So let's try just shape 19, but you can play around with the shape that you're giving it. I'm also going to change the color. So I'm going to do comma color equals, and in quotes, I'm going to write purple. So for this line here where I'm adding the Harvard data, I'm going to define the shape by saying shape equals 19, and the color by saying color equals purple. And remember to add your plus sign at the end to tell ggplot that you want to continue into the next line. Okay, that looks good to me. I did a quick review, so I'm going to highlight all of these lines of text and hit run. And it might take a sec to come up. And then our new figure has showed up in the plot panel on the right. So awesome. We can see here that we have now added a purple circle to our map. So that's great. It worked. And just to reiterate, you can play around with this. So if you wanted to change this color, you could. So you could say color equals blue. You could even change the size of it. So let's do comma size equals, let's try 2. So you can change it like that, and we'll just run it again and see how that changes our map. Great. So unlike before, now we have a blue point location, and it looks slightly bigger. So now we have learned that we can import data into R that has different spatial projections. We explored those spatial projections using the ST-CRS function and specifically looking at the project string. And we also looked at the extent by using this B box or this bounding box function to look at the different units and the different extents that those data were taking up. But because we don't have to reproject vector data to plot it, we were able to use those data natively in our plot. So we didn't have to do any reprojection with our vector data, unlike what we had to do for our raster data. So now on your own, I'd like you to create a new map. And this time, this won't be a map of the full United States, but just of the states in the northeastern part of the US. So we're going to create a map that focuses on the Northeast region to be more, to just show the location of the Harvard plot more precisely. So the challenge, make a comment, the challenge will be to create a map of the US Northeast states, add the Harv Tower location, and give your map a title. So go ahead and pause the video now to work on this challenge by yourself. Again, you're creating a map of just the Northeast states. So take a look at your data folder and see if you can find what data you'll need to use. You're going to add the Harvard Tower location, and you're going to give a map a title. Feel free to change any of the visual look of the data at all by changing the sizes or the colors if you want to customize your map a little bit. So pause the data now and then turn the video back on when you want to see a solution. So for the challenge, we're going to work with the Northeast states data layer. So we are going to have to import a new data layer to our R environment, So to import the data, we're going to use the function stread, and I'm going to call this data layer, let's see, Northeast states boundary underscore US, sorry. So it's NE underscore states underscore boundary US. You could have given it any sort of informative name that you selected. So I'm going to assign that object name and then use stread as we did before. And within this, we'll use data equals, oh, no, sorry. See, even I have a hard time remembering this. Within this, let's go back up. So in this stread function, remember we want to use quotes and point it to the data layer. So it'll be in our data folder, in our vector folder, and then we're looking for the Northeast data. So I don't quite know what it's called, but I can scroll through all of my data layers and look. Okay, this seems right. So we have the boundary US state and the Northeast. So I'm just going to quickly take a look at the other files in this folder. And yep, that seems like the most appropriate one. So I'm going to click on that and R Studio will complete it for me. Okay, so step one, we've imported our data. Let's check out the projection just because we know how to do that. So I'm going to use the function that we used up here before, stcrs, to look at the project string, just because it's new data and I want to see what it's all about. So stcrs, and we'll do Northeast state boundaries, $, proj4 string, and I'm going to run that line. Okay, and this looks familiar. We have our latitude and longitude, WGS 84. So this is what we saw before with our US and country boundaries. So no problem. Well, we know we can continue to map even if it's in a different projection. So let's create a map of the Northeast states and the tower location. So we'll use ggplot again. And I'm going to use this as a guide. I'll type it all out, but I know that I have this as a reference. So ggplot function +sign on a new line. we'll use GeoSF. Within GeoSF, we'll give it the data of our Northeast state boundaries. Again, I'm using tab complete to have RStudio help us out. Plus sign to continue it. We know we want to give it a title, so GG title will be, let's say, map of the Harv Tower location. Plus sign to complete. And then just as we've done before, we need this chord SF. So CORD_SF. We don't have to put anything in that function. So I know this figure is not complete, but I just want to check and make sure that this new data layer that we entered will map. And then I can build and add on to this. So I'm going to highlight all 4 of these lines and hit run and see what comes up. Great, so we have taken our Northeast states boundary layer and we've created a new figure with just those states in the Northeast. This looks great. So now we want to add our Harvard Tower location. So I'm going to add that under my state boundary layer. So I'll create a new line after my state boundary layer and above the title, and do what we do for adding data, where we'll use the function geom_sf and then call data equals point harv. Outside of this function, we'll end with a plus sign. So now we have added a new line of code to our ggplot block where we are calling our point location data. So let's see how this works. We'll highlight the whole block and hit run. All right, so now we can see we've added our point location. So we have our point location of the Harvard Tower and the state boundaries of the states in the Northeast. Now you can go ahead and customize this plot however you want. So like we did before, we could do color equals, let's say green. We could even like change the size. Maybe we want these to be a little bigger. So we could say size 2. Great. Now, I don't think that necessarily looks good, but that let me play around with some different aspects of this map. So that's the basic map. You can go ahead and change how you want it to look, changing the size, color, maybe point type. But now you have added in a new layer, so just the Northeast states, and added your point location to your map.